Welcome back. We're going to continue on with the quadratic formula. So here is part C and D. And so just like with factoring, first thing we need to do is put this into standard form. Now, typically, the easiest thing would be just to move this one term over, but we really want to keep this x squared positive. It truly doesn't really matter that much when we're using the quadratic formula, but it does matter when I'm using square root method or factoring. So let's just kind of keep it positive. So instead of subtracting this over, I'm going to subtract the 10x over and add the 61. So now this equation is x squared minus 10x plus 61 equals 0. Okay, now from here, I can list my A, B, and C. So A is still 1, B is negative 10, and C is 61. Now we don't have the quadratic formula on this page, so I'm going to write it. Honestly, the more times you write it, the better you are at memorizing it. Not super important, since again, this is open notes, we have a note card, but it doesn't hurt to memorize it. And so we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I now have my formula and I know what all of my variables equal. So now this is just substitution. So negative b, if I have negative 10, that's a positive 10, plus or minus the square root of b squared. This negative 10 must go in parentheses, minus 4 times a times c, all over 2 times 1, 2 times a. So clean it up. We're going to have 10 plus or minus the square root of something all over 2. Let's figure out what goes under that radical. So I'm putting what's under that radical right in my calculator. Just the way it looks, and we get negative 144. Okay, we need to break this down. Now, we have a negative under a radical, and we have stated in the first lesson of this module in our mathematical commandments for a domain that thou shalt not have a negative under a square root, because if you put the square root of negative 144, you have an error. That's a non-real answer, which we said on the previous page, we were going to get some complex answers, which are my imaginary. So when I get a negative under a radical, the first thing I'm going to do is separate the number from the negative. This is the same as 144 times negative 1. And this negative 1 is my I. And I'm going to go ahead and circle it because that I comes out of the radical. Now we can break down 144. And 144 is a perfect square. That is 12 times 12. There's my pair. So this simplifies to 10 plus or minus 12i all over 2. And this will simplify further because what's in front of the plus or minus and behind the plus or minus and what we're dividing by are all divisible by 2. So 10 divided by 2 is 5. 12 divided by 2 is 6. 2 divided by 2 is 1. So you can put that all over 1, but not necessary. Now we can kind of check this answer in our calculator using the graph, but kind of not really either. when I graph this, I'm putting this in. And when I graph it, maybe, where is my graph? Where's my graph? Okay, this has a y-intercept of 61. I'm going to zoom out on my graph. Let's go negative 100 to 100. And there's my quadratic. Okay, if I actually zoom out a little bit more, maybe we can get more of that quadratic shape. Okay, but the big thing is, I don't have any x-intercepts. If what you are solving for are x-intercepts, and you get an imaginary number, that means you have no x-intercepts. So imaginary answers equal no x-intercepts. So I can't really check, is this the right answer? But I can check, yes, I was supposed to get an imaginary because it's not touching that x-axis. Okay. Here is our last problem using the quadratic formula. I highly recommend, since it is our fourth one, that you pause this video and try this one on your own. Okay, I hope you've had time to pause the video. Let's go through and solve it, and hopefully you are checking your answer and finding any mistakes that you made or patting yourself on the back for doing the job well done. First thing we need to do is put this into standard form. So we need to subtract this 6x over. So this is 12x minus 6x plus 10 equals 0. So I am using this to label my A, B, and C. My A is 12, my B is now negative 6, and my C is 10. Now, one thing to kind of note here, I do have a GCF here of 2, and if you wanted to, you could divide a 2 out of everything and have smaller A, B's, and C's, but honestly, it's not really necessary, so I'm not doing it, but you could do it and get the same answer. So I'm going to write my formula of negative b plus or minus the square root of b squared minus 4ac all over 2a. So that now I have the formula and I have all of my variables. Now this is just substitution. Negative b, if I have a negative 6, negative is a positive 6. Plus or minus the square root of b squared. The 6 or negative 6 must go into parentheses. Minus 4 times a, which is for the first time is not 1, so 12 times c of 10 all over 2a, which again, a is 12 this time. So simplify this up. We'll figure out what goes under this radical. 2 times 12 gives me 24. And let's see what goes under my radical. We get negative 444. Okay. So let's break this down and simplify it. The square root of negative 444. First thing I want to do when I see that negative, I know I'm going to have an imaginary, but I want to break that up. I'm going to have 444 times negative 1, and that negative 1 is my I. I'm going to go ahead and circle that so I remember it comes out of the radical. Now let's break this down. We're going to have 4 and 111. 4 breaks down to 2 and 2. And then this one's divisible by 3. And that's going to give me 37. 37 is a prime number. So I have a pair of 2s and this I comes out. So this is going to be 2 times I. And then I have 2 lonely things staying in. So we'll multiply 3 and 37 back together to get that 111 in the radical. So this is x equals 6 plus or minus 2i square root of 111 all over 24. We can simplify this a little bit further. We are looking at 3 numbers. What's in front of the plus or minus, behind the plus or minus, and what we're dividing by. These are all divisible by what? By 2. Now these are divisible by 6, but that 2 is not. So what I'm dividing everything by is 2. And notice, it does not matter that that square root of 11, that 111 is not an even number because we're not touching it. What's inside radicals does not mingle with what's outside. So we have 3 plus or minus 2 divided by 2 is 1. So you can do 1i or just I. Square root of 111 all over 12. And this is my final answer here. So checking the graph one more time. Okay, I'm putting this in my calculator. And this one, let's go zoom 6. Oops, just a little bit above my window. And as you can see again, it does not touch that x-axis. So I can't fully verify that this answer is right, but I do know it should be imaginary because it's not touching the x-axis.